Hello everyone and welcome back. So far in this chapter, all about transformations and symmetry, we have already learned about translations, reflections, and rotations, 3 different types of congruence transformations. Today we are going to learn how to draw glide reflections and other compositions in the coordinate plane. Now compositions basically just means putting different transformations together. Now one special composition of transformations is called a glide reflection. It's a slide and a flip. So it's a translation followed by a reflection in the line that's parallel to the translation vector. Let me explain what that means. This is commonly modeled by footprints and others in the real world. So let's say that we're starting here as our pre-image with this first footprint. Now first we have to do a translation. So we slide forward a bit. Then we have to do a reflection in the line that is parallel to this translation vector. So we have to have a reflection over a line that's parallel to the vector. Notice that these 2 highlighted lines are parallel. So we have to reflect over that line to find our image. We can repeat this process as many times as necessary. Now let's go ahead and try one on a coordinate plane. You can see I've drawn it already, but let me explain it to you. First, it tells us the vertices of the triangle JKL. So the first step is to plot the vertices of triangle JKL. Next, it says to graph the triangle and its image after a translation along 0, 4 and a reflection in the y-axis. Something that's super important to note about transformations and compositions. With a composition, you always must go in the order that is given. Now for this one, first it tells us to do a translation along 0, 4. So that means go horizontally 0 and go vertical 4. So remember, if this is a positive 4, it means go up. So all we have to do is take every single point and take it up 4. For our triangle. So we'll count 1, 2, 3, 4 for every single one. Notice our translation vector on this is a vertical vector because we're moving straight up. That means that in order for this to be a glide reflection, we'll have to reflect over something that's parallel to vertical. That's obviously going to be a vertical line again. It told us to reflect over the y-axis. Notice the y-axis and our translation vector are parallel to one another. That's what makes this a glide reflection. So remember, to perform a reflection, you have to see how far away is each point from the line of reflection and go the exact same distance on the opposite side of the line of reflection. We'll do that for every single point on triangle JKL. And something new when we're doing compositions is that when we do the second image, we write it in this way with 2 primes above the letter. So we have the second image of J, the second image of K, the second image of L. This will show that it's the second image instead of the first. It's important to keep in mind that you should always write out the first image and then the second. It will really help for you to draw this out every time. Alright, below I have an example for you to practice on a glide reflection. So they both deal with triangle PQR. Plot those first, then you can try the 2 on your own. Here are the correct answers for those. Notice in both cases, the translation vector is parallel to the line of reflection. That's what makes this a glide reflection. Now, if it helps, it sometimes might be necessary to write out the points. For example, that's what I did here when I was reflecting over y equals x so that I could figure out when I switch x and y, what are my points going to look like. Alright, let's do another composition, not just a glide reflection. Again, you still just have to follow the order that is given. So there's nothing really quite new about this. We're just putting everything that we know about translations, reflections, and rotations all together now. So we go ahead and graph segment CD, and it says first to do its image after a reflection in the x-axis and a rotation 90 degrees about the origin. So we have to complete the reflection first. So we'll go over the x-axis. Remember, see how far away is each point from the line of reflection. Go the same distance on the opposite side. Once you have that image completed, now we'll do the image of that image, the second image. So the second step was a rotation 90 degrees. Again, this is a case where I would suggest writing out the points in order to figure out with the 90-degree rotation rule, what are my points going to be. So I know that I have to do negative y, comma, x. So first step is to make the y, multiply it by negative 1. So negative 1 times negative 1 is positive 1. Then switch x and y. So it becomes 1, negative 7. Do the same thing for the other point and then graph it on the coordinate plane. I want you guys to try this too, so I put 2 practice problems for you to try below. Here are the correct answers for those practice problems. And finally, I want you to answer this question. Does the order of transformations matter? Does it matter, for example, does it matter if we do the reflection in the y-axis first or the translation first? And why does it matter? Can you tell me when it matters? Can you tell me why it matters? Anything about this question, does the order of transformations matter? That just about wraps it up with transformations. We'll be looking a little bit more about a couple other compositions. After that, we'll deal a lot with the symmetry part of this chapter. So I'll see you soon to talk about those new topics. Bye.